welcome to this second video, so the first coding video in the Understanding Neural Networks playlist. So now we're implementing what we have learned in the first math video. There are always two coding videos, one for beginners and one for intermediates and advanced obviously. But if you're that advanced, why you even watch my videos, but whatever. So this one is the beginner video. First of all, if you don't have Python or PyCharm installed, there is a video in the info card right now, so go watch that and do what I say there and then come back. So now I expect you to have PyCharm and Python installed. So you should have, so first of all, if you open PyCharm, you have like this small window, and then you make a new project and name it something like neural networks or whatever. Then to get you probably have something like this, and then to get your first Python file, you have this this folder here, which should have the same name as your project, and then you right-click, new and Python file, and then you name it something, press enter. I already did that, so I have this right now. I called it one-to-one because I'm a lazy programmer. So what we have to do in this video is implement all of this, everything we had in the table. So we have the weight, input, hypothesis function, target, loss function, and gradient descent. So first of all, I'm going to define. So we need two things in this video. So for one, we need something called a variable. So this is a variable where you set some name, something. You can also just call it W. You can really do whatever you want to a number. So variable is basically used to store information to be referenced and manipulated later on. So we can later on manipulate that by, for example, doing weight equals 1, or we can use this by, for example, saying print weight. So what the print does is that we output it to this thing down there. So if you want to run your code, you go up here to the run section and use the second run, not this one, the second one. And once you did that, maybe you have to maybe you have to click on the right name here, probably not. And from now on, you can always just hit this button on the top right. But for the every time you if you run a file for the first time, you have to use this one, and from now on you can always just use that. So this will print the information that is stored in this variable weight, which is a 0 here. So this is just some path, and this is just some telling you that you don't have an error right here. So that's that, and now we have you have to note that there's this green line. Just ignore the green line for now. What it basically tells you is that you haven't written your code in the most beautiful way possible, which is totally fine. So what it tells me here is that, oh no, there's more than 2 blank lines in front of this, so it wants me to do this, because this looks way better. But really, don't worry. But if this is red, then you have a bug. But the green ones, you shouldn't really care that much. So now we use the variable. So we use weight as a variable. We set target as a variable, being equal to, let's say, 1, and the input as a variable is equal to 2. It's important that you don't use input with a lowercase I, because that's a predefined function in Python, and it's just like if you say print is equal to something, it's also gonna mess with this, because print is a predefined function from Python. That's why you cannot use it, but uppercase I and you're fine. So now we want to define the hypothesis function, and now what I want to do is just say this, and now you realize that well, we need this to be, what is it, x times w, first time x and w, and it doesn't just work like a variable. So what we need here is a function. So a function is a set of statements that does some computation and then outputs something. Some output, right? So you define a def for define this function h of w and x. So this is the syntax. You have this open bracket, and then you have some parameters. So this is the input you can give, and then you have just this double dot, and then you have to skip a line, you have to tab in, and then you can say return. So this is basically just like this equals. You just say, alright, we return. We need this because you can also do computations before that, because you can also say w equals x. So we set this w equal to the x and stuff, and then later on you can return it. So, but now we only need this one line. We say we return w times x. And here it's telling me again that it's not the most beautiful code because I didn't have this line in, but eh. If you get used to this from the start, it's probably better. So probably if there's a green line, you should somewhat care about it because your code just looks better if you do it. So this was that. Now we did loss function. So note that this just defined it. This is actually not doing anything yet, but we can call it just like a variable. So we can say h of. I have to remove this shit. H of, and then we can say w is our weight. So now this w will be set to our weight. And then we also need the x, and then we put in the input. And now this is already a prediction that's going to make. So run it. So go here. If you haven't run it yet, I can already go click this one. And the prediction is 0. Because we have a weight of 0, and if you multiply 0 by 2, you get 0. And now, okay, so now we define the loss function. So that's basically how it works. So you can just call a function later on, and this actually does something. This doesn't do anything yet. Oh, this just defines it. Just like this one. This just puts it in the just puts a 2 in this input placeholder. So now we define the loss as, let's see here. We need the w, we need the x, we need the y. Then what we say is we return, because we want to return this obviously. So return basically means that you get this back, right? So we want to return this stuff. So right here you can say you can actually call the other function from within this function. Let's do another line, skip again. So we can say we have this w, and we can use it here, and this x. And now we say minus the y, and that squared. So this is the donation. This is how you put a squared. This is a cubed. This is the power 4 and things. You can also just take this, copy, then do times and do it again. But this one looks better in my opinion. This one's also more efficient. So we have this loss function. Great. So now we obviously need the gradient descent. So we define gradient descent. Dip, 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 dip. So let's ask ourselves, what do we need? Think about this yourself. Maybe you can pause the video if you want. So we need let's see, I actually wrote this pseudocode before, didn't I? Yes, I did. So what we need, it seems like we need a w, because we want to change. We have to know this w because we have to know where we are on this. So we have to, for the derivative we need it. Then we also need x. We also need target, and then we also need some alpha. So alpha is the learning rate. Remember that the learning rate is needed so that you don't overshoot. You don't take too large steps and go to orbit. So right here we set change equal. So this is now a variable that is stored within the function. So this variable cannot be used here. I cannot. So if I say change here, change equal to, what was it, the derivative of the loss, which we calculated earlier. This is just a mathematical thing. This doesn't take any programming skills. Just write it down. Take this, you did that, times x times alpha. And this is the derivative. This is negative because we want to decrease it, and then we have the times alpha. And now we say the weight equals, so w, this is not the weight, yet. And we say w equals w plus change, and then we return w. So basically what we did here is we have made a new variable that's only used within this function. I cannot call it later on, like down here. This is a internal variable. Then we set that equal to the negative derivative times that alpha. Then we applied that to the, so this is going to be the weight. So when we call this, what we do is we have gradient descent. We put the weight. So this is going to be the weight. So what we do here is we have this w being set equal to the weight, and then we change that by this change, and then we return it. So what we want to do is we want to set the weight equal to this new gradient descent with weight, input, target, and alpha being some small number like 0.01. Oh, this is too many blank lines, I guess. Yeah, why not? So, and now this, what this will do is this will compute a better weight, and this will then apply it. So we set the weight actually equal to this internal variable that gets returned here. So this gets computed with that change. So this should be a better approximation mathematically. Again, if you don't understand this, watch the last video, the last math video, and then we apply this. So if we want to now print the loss, because we want to actually know if it does better or not, so we do weight, input, target, like this. Not enough blank lines, my friend. And then we run this. See, first we have a loss of 1, and now we have a loss of 0.92. Now this is pretty good because the loss is decreasing. Now, obviously, one step is not enough. We have to do this over and over again. Obviously, what you could do is copy, paste, paste, paste. Oh no, not even like that. But that's quite unprofessional. So what we use here is a for loop. So what we do is that we do for, and then some variable like I, and then we do in range 10. So this is now doing the following. Like this is basically means like the following, everything that's tapped in. So you have to tap this in. So this is doing, yeah, I give you a blank line. So this for loop does the following things. Everything that's tapped in. This is not tapped in because this is the tap we did. So it does this 10 times. And what we could also do is this I for the first one is 0, and then for the second iteration it's 1, then for the third iteration it's 2. And we could also use this, but we don't use this here. But this might also be useful. So this basically just counts up from 0 to 9. Note this is not from 1 to 10, because computers start counting at 0 for some reason. I mean, it's useful, but it's not very intuitive. So if you run this now, we can see our loss decreased from 1 all the way, because at every iteration we also print it again because of this function, and we print it again at the last one. So we have and it's decreasing to a 0.44. Now 0.44 is already pretty good, but we can do better. So we can either increase the iterations, which will be quite computationally expensive, but we already have 0.00028, which is already pretty good. I mean, that's basically almost perfect, right? But what we also can do is we can change this learning rate. So this one seems to be very slow. This one, it does like a very slow percentage. So what we could do is we can increase it. I'm going to increase it tenfold right now. What can happen here is that it just goes to orbit, as I said before. Oh, so this is way better. So what this basically means, this E at the end here, you can see E minus 13. If this is a minus, then that means there are 13 zeros in front of the first number. I mean, there are 12, because you remove this dot 13 times to the left. So this is a really small number. This is 32 zeros in front, and so that's a very, very small number. You can basically treat it as a 0. So that's a way better way better alpha. But if we put this too high, I'm gonna put this to 1 now, and I probably know what happens. Yep, this happens. So this for more and more iterations, it will just increase because of the slope, and it just takes a too big step, and then the slope gets even steeper, and it takes a very huge step, and yeah, that's how this happened. So you have to find the right one. Maybe 0.2 is even better. Yeah, 0.2 is even better. So yeah, this is really good. Just says, yeah, this is basically 0 is what the program said at this point. So yeah, 0.2 seems to be maybe, you know, you can play around with this, and you have to, because sometimes it's just converging too slow or too fast. But yeah, yeah, that's basically it. Now you know how to implement the one-to-one gradient descent, and see you in the next math video.